you're watching my video on pressure in mechanical systems. If you recall from our previous unit in mix and flow of matter, we also talked about pressure. In that situation, we talked about how pressure can affect the states of matter and the chemical reactions that can take place. In this unit, we'll be talking about how pressure can affect how machines work and can affect how easy or hard it is to lift an object. So, what is pressure? Pressure is the amount of force over a given area. So I like to use this picture as an example. When we apply this force of whatever this is, this block of wood, when we apply a force down onto this surface, we are applying a force over this area, right? Because that's what we're applying the force on, right? We're applying a force on this area. So this is where all the force is being felt. And so the pressure is equal to force over area. So if I applied 40 newtons, right, 40 newtons over an area of 2 meters, then I'm applying a force or a pressure of 20 pascals. 20 pascals. So you need to remember that pressure is measured in pascals. Pressure is calculated by the equation force over area. Again, there is a triangle you can use. This is a bit of an ugly triangle. Let me just restart that one. Right? You can use the triangle here. Right? And so you can slot in the specific units into the parts of this triangle to find out what you're trying to look for. Right? So if I have force here, right? I have A here, area, and I have pressure here, right? If I wanted to find out what the pressure was, I would cover up the pressure. Force over area would give me the pressure. If I'm looking for force, it would be pressure times area. And if I'm looking for area, it's force over pressure. So all I would need to do to calculate any part of this equation would be to use that triangle. What this also means is that pressure increases as you apply force over a smaller area. So let's take a look at our previous example. We had 40 newtons of force, right, over, let's say 4 meters instead. 4 meters instead. Well, we create a pressure of 10 pascals, right, of 10 pascals. But if we reduce the area, but keep the force the same, so 40 newtons again, divided by 2 meters, that makes it 20 pascals, right? So you can see, as you decrease the area, but maintain the force, you can increase the pressure. So the pressure is directly affected by how much area you're applying your force onto, as well as how much force you're applying. Because naturally, if you increase the force, you increase the pressure. So, Pascal's law. This rule states that when you apply pressure on a fluid, liquid or gas, it applies that pressure unchanged in all directions. So as you fill a balloon, the pressure that balloon feels when you're filling it with air is felt across the balloon. I probably shouldn't use red. It's felt across the balloon unchanged, right? It feels that pressure unchanged throughout the balloon. Throughout the balloon. It feels that pressure unchanged throughout the balloon. So what's happening here is if you're putting an amount of pressure into the balloon as you blow it up, that exact same pressure is felt throughout the balloon. So, in this example, if we applied a force of 30 newtons over an area of 1 centimeter, well, that's 30 newtons over 1 centimeter, which can also be used or said as 30 pascals, because again, pressure is measured in pascals. 30 pascals in all directions. It's not divvied up, it's not divided, it's felt the exact same throughout the balloon. So Pascal law states that If you apply a pressure to a fluid or gas, to a liquid or gas, that pressure is felt equally and undivided across all directions. So, let's say let's say the left piston is 3 meters long in this example, and the second piston is 15 meters long. We apply a force of 100 newtons to lift this car, right? How much force is applied by the right piston, right, by the gas? So how much force is applied by the right piston, or applied onto by the gas in the right piston? So we apply 100 newtons of force over 3 meters, and this force is felt by this gas and pushed up by this piston. So how much force is felt by that piston? Well, at first you might think, this is a very hard question. How can I find the amount of force? Well, remember, Pascal's law states that the pressure applied is unchanged in all directions. What that means is the pressure applied here, because we're applying pressure to a gas, is the same pressure here. The pressure is unchanged. So what's the pressure of this setup? What is the pressure here? Well, how much pressure here must also equal the pressure here. So if we can figure this out, we know this pressure. So we applied 100 newtons of force over 3 meters. Right? So pressure is calculated by force divided by distance, 100 divided by 3, which gives us 30 newtons over meter squared, or 30 pascals. So now we're applying 30 pascals. Well, we know, according to Pascal's law, that the pressure must be the same. So on this piston must also equal the same pressure. So we know that this must be 30 newtons, or 30 newtons per meter squared, or 30 pascals. 30 pascals. Well, we also know this is 15 meters across. We also know that this is 15 meters across. So pressure, again, equals force over distance, or force over meter. So if we know what the meters are and we're missing force, we need to know something divided by 15 is 30 pascals. Okay, well, now we know that the pressures must be equal. Now we know what part is missing. We could make the equation look like this. 100 newtons over 3 meters, because that's the pressure that we calculated here, equals force over 15 meters, because we know that force divided by distance is pressure, and both of these must be equal, because Pascal's law states that the pressure on both sides must be equal. Okay, well, now we are only missing one thing. So this looks familiar to our other units in math, proportional reasoning. So we can take 100 times 15 divided by 3, and that'll give us our F. The fish trick comes back again. So again, we go 100 times 15 divided by 3, 500. So we're applying a force of 500 newtons. You can see how much more force we've just applied. We have now multiplied the amount of force by 5 times in this setup. So pressure and Pascal's law is very useful for day-to-day machines because it multiplies the force you use by a wide margin. So let's do some practice question. A piston with an area of 21 square centimeters pushes on a liquid with a force of 38 newtons. The far end of the pipe connects to a second piston with an area of 100 square centimeters. What is the force of the second piston? Well, first things first. We're going to deal with meters, right? That's what our calculation was. So we have 21 square centimeters. Well, we can turn that into 0.21 meters because 21 centimeters divided by 100 gives you 0.21 because 100 centimeters are in a meter. We also have a second piston with an area of 100 centimeters. Well, again, if you divide it by 100, you just go move the decimal 2 spots, right? Yeah, if you move the decimal 2 spots, you get 1 square meter. Because again, 100 centimeters are in 1 meter, so 1 meter. So now we have our two distances. We have the amount of force we put in. How much force is felt by the second piston? Well, we know, let's say piston 1, P1, equals force, right, divided by area, and P2 must also equal P1. Well, we can find P1, right? P1 is the same as saying, well, force is 38, so we have 38 newtons divided by, well, it's over an area of 0.21 meters, so 0.21 meters, right? So we just do that. 38 divided by 0.21 gives us a pressure of about 181. Let's round up. 181 pascals. 181 pascals. Cool. So now we know that P2 must also equal 181. So we know that 38 newtons, right, divided by 0.21 must equal, well, force again. Well, we don't know what that is, so we'll make that x, because that's what we're looking for, over 1 meter. Well, again, I can just cross multiply and divide. So I'll use a different color. 38 times 1 divided by that. Well, in this case, we end up with 181 newtons of force, right? So we've dramatically increased the force we are using. Now, the reason why it's the same is because we had 1 meter. In this one, it'd be a little bit different. A system is used to lift 20,000 newtons vehicle in a garage. If the vehicle sits on a piston of an area of half a square meter and a force is applied to the piston of the area of 0.03 square meters, what is the minimum force that must be applied to lift the vehicle? So we know that we're lifting a 20,000 vehicle in the garage, 20,000 newton vehicle in the garage. Okay, so we know that the second piston is 0.5, and we apply a force to a smaller piston with that. Okay, well, we're looking for the force applied to 0.03 meters, right, must equal, well, we know the force, which is 20,000. 20,000 newtons over 0.5. Well, if you divide by 0.5, that's 40,000. But we'll work with that. So, again, different color. 20,000 times 0.03 divided by 0.5, which would give us our answer. So let's try that again. So we go 20,000 times 0.03, 600 divided by 0.5, which would give me 1,200, right? So x needs to equal 1,200 newtons. So hopefully that made sense. These calculations can be a little bit tricky only because you need to understand that the pressure on both sides, meaning that the force over area on both sides must be equal. So if you're given one of the sides and you know what the pressure should be, then you can just solve for the missing side. So we see Pascal's law applied in hydraulics and pneumatics. Again, another thing we talked about in mix and flow of matter, right? Pressure is applied to oil and liquid, other types of liquid in machinery to multiply the amount of force used or applied so that we can lift heavy objects or move massive amounts of dirt. Pneumatics do the same thing with air. So hydraulics use liquid, hydro, as in water, and pneumatics use gas. Both use their respective fluid under pressure. Both apply Pascal's law, and we see these types of machines every day. So hopefully these calculations weren't too difficult and they weren't too tricky, and I'll see you in class. Have a good one.